Hello everyone. In this class we will discuss the most important questions from current electricity chapter for your NEET exam. Look at the question number 1. The question is, in the given circuit total power consumed is 150 watt. Then what is the value of R? That is the question. The circuit is given. You can see that two resistance 2 ohm and this R are connected in parallel. So we have to find out this value of this another resistance R. Total power is consumed, which is given 150. So we know that the formula of power is nothing but V square upon R. Now here two resistors are there in the parallel. So in the parallel connection, to find out the net power, we have to just add up the power in this branch, which resistance R plus power with resistor 2. So if you apply the formula, then total power consumed, which is given 150. So 150 is equal to, if you apply the formula here, V square upon R, which is R, plus here also V square upon R, which is 2 in the second branch. And the value of V is 15. So if you apply the value of 15 also, so 150 is equal to 15 square upon R plus 15 square upon 2. So if we take this 15 square upon 4 that side, so 150 minus 15 square, which is 225 upon 4, sorry, it is 2, is equal to 15 square, which is 225 upon R. So if we do the cross multiplication, 150 into 2, that is 300, and 300 minus 225, which is 75 upon 2, is equal to 225 divided by R. So if we do the cross multiplication, so R will come here, 2 will come here, and 75 will go down. So R is equal to nothing but 225 into 2 divided by 75. Okay, like this. So if we cancel out 75, 3 is 225 and 3 2 is 6. So resistance value, that is nothing but 6 ohm. So our answer B is the correct option. Okay. Look at the next question. The question is, when the temperature of the copper and germanium strip is decreased. Okay, so this word is important. Temperature is decreased from the room temperature to 880 K. So we know that for a conductor, the copper is conductor. So for conductor, if temperature increases, then resistance increases. And for a semiconductor, which is here germanium, temperature increases, then resistance decreases. So here, but temperature is decreases in both the case. So what is the resistance? We have to answer it. So resistance of the copper, if the temperature decreases, then resistance also decreases for copper. And for germanium, temperature decreases, then resistance will increase. So our correct answer is D. Resistance of the copper will decrease and the resistance of the germanium will increase. Okay, because as a copper is a conductor, hence the decrease in temperature, resistance also decreases. And germanium is nothing but semiconductor. So if you decrease the temperature, resistance will increase. Okay. Move to the next question. So the next question is, a 3-volt battery with negligible internal resistance is connected to the circuit shown in the figure. So the current I in the circuit will be, we have to find out the current I. So we know the formula V is equal to IR. So I is nothing but V upon R. Okay. So we have to find out on the circuit, first of all, total resistance net. So we can see that this 3 ohm resistance and this 3 ohm resistance, they are connected with the single line. So this is in the series connection. So in the series connection, we have to directly add up. So this 3 plus 3. So net resistance is 6 ohm. Then this 6 ohm and this 3 ohm. This is in parallel connection. So in parallel connection, we are solving 1 upon, or let's say parallel, is equal to 1 by 3 plus 1 by 6. So we'll make the denominator to be same. So if I multiply 2 and here 2, so denominator is 6, which is equal. So denominator is 6 and 2 plus 1, that is 3. So 3 2s are 6. So answer is 1 by 2. So the net resistance is, if you take the reciprocal both the side, resistance is 2 ohm. So if you apply the value here, our potential is 3 volt. So 3 upon resistance is 2. So 3 by 2 is nothing but 1.5 ampere. So in this question our correct answer is B. Look at the next question. Power consumed in the bulb of 1000 watt when 220 volt is supplied is given. When connected to 110 volt, then what is the power that we have to find out? So on this concept, in the recent exam also question was come. So power formula we know that P is equal to V square by R. So when it is connected with 220 volt, then the power is 1000 volt. So what is the power when it is connected with 110 volt means? That is the question. Okay. So if we find out the first power, let's say formula, let's say P1, the formula is V square by R. So we don't know resistance. So we'll find out, let's say, what is the resistance. Okay, here no need to find out resistance. We will take the ratio directly. So for P1 it is V1 square by R, and for P2 is V2 square by R. So if we divide this both, then we will get P1 upon P2 is equal to V1 upon V2, V1 square upon V2 square. Okay, so P1, which is given to be 1000 watt, P2 we have to find out, V1 which is given to be 220 watt, and V2 is given 110 watt. So P1 is 1000 upon P2 we have to find out is equal to V1 square. So V1 is 220, so 220 square upon V2 is 110. Okay, so if I make it in the whole square form, so 1000 upon P2 is equal to 220 upon 110 the whole square. So we can cancel out this easily. 11 2s are 22, so 2 square is nothing but 4. So 1000 upon P2 is equal to, we'll get 4. So we have to find out P2. So if we take this P here and 4 in the denominator, so we'll get 1000 divided by 4, which is equal to 250 volt. So our answer is 250 C. Look at the next question. Two wires are made of same material. The ratio of their length is 4 upon 3. That length ratios are given. So let's say L1 upon L2, which is given to be 4 upon 3. And the ratio of the radii is 2 by 3. So R1 upon R2 is given 2 upon 3. And these two wires are connected in parallel. Now this word is important, connected in parallel. So the question is, ratio of the current flowing them will be, means we have to find out I1 upon I2 is equal to what? So we have to find out the first of all relation between current, length and radius. Okay. So both the resistance are connected in parallel here. Okay, so the circuit will look like this. So in the parallel connection we know that current is dividing in every branch, but the potential difference across them will be equal. So if we apply that formula, if the potential difference is same, so we can write down in both the branch I1 R1 is equal to I2 R2. So we have to find out what I1 upon I2. So if we take I2 in the denominator, so I1 upon I2, which is same as this R1 will go in this denominator, so R2 by R1. Now we know the formula of resistance. The resistance formula R is equal to nothing but rho L upon A. So if we apply here, so it will become rho, let's say L2, because this is resistance R2, so length is L2 upon area is A2, divided by rho L1 upon A1. But okay, so length ratio is given. Now we have to convert this in terms of radius. So area is nothing but, here it is, we will consider it's a wire is a round shape, so it is area will be pi r square. So A1 and A2 we have to put pi r1 square and pi r2 square. So I1 upon I2, which is same as, now this resistivity, because the material is same, resistivity is same, so this rho and rho will get cancelled. So L2 divided by area A2 is nothing but pi r2 square divided by L1 upon area A1, so pi r1 square. So this pi and pi is fixed, so that will also get cancelled. So if we solve this, L2 divided by L1 as it is, and this quantity will come in the numerator, R1 square divided by R2 square. Now I have to just substitute the value. This is L2. So L1 upon L2 is 4 by 3, then we required here L2 by L1, so that become 3 by 4 multiply by R1 upon R2 the whole square. So R1 upon R2 is 2 by 3, so 2 square is 4, 3 square is 9, so this 4 and 4 will get cancelled, so answer is 3 by 9 for this question. And 3 by 9 is nothing but, if we cancel out 3 by 9, we will get what? 1 upon 3 is a correct answer. Look at the next question. Resistance of bulb having 100 watt when 200 volt rating while it is being used is 10 times its resistance when not in use. So resistance of the bulb during not in use will be, okay, so one resistance is given, let's say that is R1. Exact value is not given, so first of all we have to find out the value of resistance. So what is given? Power is given, which is 100 watt, and volt is given 200. So we know that power formula P is equal to V square by R. So R will be nothing but V square upon P. So V is here 200, so 200 square upon power is 100. So 200 square, which is 400, 2 square is 4, and square of 00 we can say it is 4 zeros upon 100. So this 2 zeros will get cancelled, so answer is 400. So this is the resistance when it is in use. Okay, so it is given that while it being used, it is 10 times when it is not in use. So this is a 10 times greater when it is not in use. So whose 10 times is 400? We have to find out that only. So the resistance of the bulb during not in use. So now it is 400. So when it is not in use, then what is the resistance? So we can say it is nothing but 40, because 40 is 10 times of 400. If we multiply 40 by 10, we will get 400, correct? Or you can find out like this also, by this is nothing but the word problem type. When it is in use, that means R1, that is the resistance, which is nothing but 10 times means 10 multiplied by when it is not in use. So let's say it is R2. So when it is in use, then resistance is 400 is equal to 10 times when it is in not in use, that is R2. So if we divide this 400 by 10, we'll get 40. Okay. So that means 40 ohm is the resistance when it is not in use. Look at the next question. This is very interesting question. Resistivity of metal B is twice the resistivity of metal A. So resistivity means rho. Let's write resistivity of metal B is equal to twice means 2 multiplied by resistivity of metal A means A. So this is the first condition. Then diameter of metallic wire B. So let's say diameter D of metallic wire B is equal to, that is also twice the diameter of metallic wire A. That means 2 times diameter of metallic wire A. Okay. If the resistance of both wire is same, okay, this is a third condition. Resistance of both the wire RA and RB both are same. Then the ratio of the length of both the wires. So ratio is, now you can see here, ratio we have to find out LB upon LA. Okay, second wire upon first wire. So how resistance, resistivity, diameter and length are related, that we have to see first of all. So the formula of resistance is nothing but R is equal to rho L upon A. But we don't want area, we have to convert into diameter. So if resistance is equal to rho L, area means nothing but pi R square. R means radius, we want diameter. So diameter is nothing but double of radius. So rho L upon pi, R means 2 times diameter. Sorry, diameter is nothing but twice of radius. So radius is nothing but R is equal to diameter upon 2. So instead of R, we have to write down diameter upon 2 and the whole square as it is. Okay. So overall we are getting R is equal to rho L upon pi pi as it is, and then d square upon 2 square is 4. Okay, so now we want what? The length. So from here, if you find out what is length, so length is nothing but L is equal to this pi r, and d square by 4 we have to multiply here. So L is equal to r multiplied by pi multiplied by d square divided by 4, and this resistivity rho will go in the denominator. So this is the value of L. So we have to find out LB upon LA. So LB upon LA. So it will become RB pi into dB square upon 4 times rho B whole divided by, so that division we will write here by taking the reciprocal. Okay, so in the denominator we have to write down the formula for LA. So LA formula will be RA into pi into dA square, and divided by, that will come in the numerator, 4 times rho A. Okay, so now we have to use this condition. We know that RA and RB are same, resistance are same, so this RA and RB will get cancelled, 4 and 4 will get cancelled, pi and pi will get cancelled. Then we have to substitute the value of resistivity and diameter. So diameter of B is given double of diameter of A, so that we have to substitute here. So diameter of B, this is nothing but bracket 2 times diameter of A the whole square multiplied by resistivity of A as it is divided by resistivity of B. So resistivity of B is given 2 times resistivity of A, so that we have to put 2 times resistivity of A into diameter of A the whole square. So if we do the square here, we will get 4 times diameter of A the whole square into resistivity of A upon 2 times resistivity of A into diameter A the whole square. So this diameter A the whole square, resistivity will get cancelled, so 4 upon 2, answer is 2. So the ratio of LB upon LA is nothing but 2. So the answer is 2 in this question. But the important thing is how to find the relation between length, resistance, and resistivity and diameter. Okay, so this thing is very important for this question. The next question is on Wheatstone bridge. So you can see that figure is given. We have to calculate the current flowing through 5-volt battery. So from this figure you can see that it is nothing but a Wheatstone bridge. Okay, so if you write down, draw it properly, then it will look like this. So we have to check this balance condition. So you can see that here 5 and 10, the ratio is 1 by 2. Here also 10 and 20, so the ratio is 1 by 2. So it is in balance condition, so no current will flow in this branch. Okay, so we can see that here this 5 and 10 are in a series. So in the series combination we are directly add up the resistance, so this 5 plus 10 become 15, and this also in series, so 10 plus 20 it become total 30. Now this 15 ohm resistance and this 30 ohm resistance, both are in parallel. So now we have to solve in parallel connection. So in the parallel connection, direct formula if we apply, we have to just multiply in the numerator 15 into 30. In the denominator we have to add up 15 plus 30. So 15 multiplied by 30 upon 15 plus 30, which is 45. So if we cancel out, 15 3s are 45 and 3 10s are 10. So the total resistance is nothing but 10 ohm. So if we apply the formula, we have to find out the current. Okay, so formula of current is nothing but V is equal to IR. So I is equal to V by R. So voltage is given 5, resistance is 10 ohm. So 5 by 10 is nothing but 1 by 2. 1 by 2 means 0.5 ampere. So the correct answer for this question is 0.5 ampere. So the next question is on drift velocity topic. It is given that in a semiconductor, the ratio of the number of density of protons and the ratio of the number of density of holes is 7 upon 5. So this ratio is given of density. and the ratio of their current is 7/4. The ratio of the drift velocity we have to find out, okay, for the proton and holes. So we know that the formula of current in terms of drift velocity is nothing but I is equal to NEAV. This is the formula. So for a electron, let's say the formula IE is equal to NE into A into E into V. And for holes, IH means H means holes, N into A into E into V. Okay, V means drift velocity, A means area, N means number, I is current. So we have to find out the ratio of the drift velocity. Means we have to find out VE upon VH. Okay, so if we divide both this formula, IE is equal to NE A E VE divided by IH divided is equal to NE, so here H A E V H. Okay, so here this A and A will get cancelled because area is same. Then we have to find out VE upon VH. This E and E also will get cancelled. So we have to remove this NE upon NH from here. So this NH will come here in the cross multiplication and NE will go in the down. So IE upon IH multiply by NH upon NE is equal to VE upon VH. So now we have to just substitute the value. So what is the number density ratio? 7/5. Okay, and the current ratio is 7/4. So current ratio, which is 7/4, multiply by density ratio, which is 5/7. Okay, here what is given? The ratio of the number density of holes is 7/5. Okay, so it is given reciprocal. So we have to take 5/7 here, because here it is holes to the electron. NH upon NE we require, and it is in the question it is given NE upon NH. So 5/7 we have to multiply is equal to VE by VH. So this 7 will get cancelled. So our answer is 5/4. Look at the next question. In a building, there are 15 bulbs of 40 watt, 5 bulbs of 100 watt, 5 fans of 80 watt, and 1 heater of 1 kilowatt. Okay, this here it is kilo is there. The voltage of the electric main is 220 volt. The minimum capacity of the main fuse of building will be. Okay, so that we do. So let's find out first of all total power. Okay, so here 40 watt power is there for 15 bulb. Okay, so 40 multiplied by 15, then plus 5 bulb of 100 watt power. So 5 multiplied by 100, then 5 fans are there of 80 watt power. So 5 multiplied by 80, and 1 heater of 1 kilowatt power. So 1 kilo means 1000. Okay, so 1 multiplied by 1000. So we have to add up all this. 40 into 15, 600, 10 into 100 into 5, 500, 80 into 5, 400, then 1000. So if we add up, we will get total power 2500. Total power P is equal to VI. Okay, so we have to find out that capacity, that main minimum capacity of main fuse, that means minimum current. So P is equal to VI. We have to find out I. So P upon V, which is equal to I. So total power is nothing but 2500. Electric mains, which is input, is given 220. So 2500 upon 220. If we solve, we will get 11.36 something. So the approximate value is nothing but 12 ampere here for this question. Okay. Next question. The current I1 flowing through the 1 ohm resistor in the following circuit is. So 1 ohm resistor is here. So from this resistance, how much current is flowing, that we have to find out. Okay. So from here we can see that this 1 ohm resistance here, this one and this one, this is in parallel. So first of all, we will find out the net resistance of this circuit. Okay. So this 1 and 1 ohm is parallel, so how to find the parallel connection? Just multiply that in the numerator and add them in the denominator. So 1 into 1 1 and 1 plus 1 is 2. Okay, so net resistance effective is, this is 1 by 2. After that the next resistance is in series, which is 2, and one more is there here, which is 2. So now this 1 by 2 and 2 is in series. So in series connection we have to just add up the resistance, 1 by 2 plus 2. So to do the cross multiplication, so 2 to the 4, 4 plus 1 5, so net resistance is 5 by 2. Okay, so we reached here. Now the next step, that 5 by 2 and this below resistance 2, this one is 5 by 2 and down one resistance is there, 2 ohm. Now these are in parallel, so in parallel we have to just multiply 5 by 2 into 2, and in the denominator we have to add them, 5 by 2 plus 2. So in the numerator 2 and 2 will get cancelled, so it becomes 5 upon, in the denominator 2 to the 4, 4 plus 5 9, so 9 upon 2. So now denominator of the denominator will go in the numerator, so it becomes 10 upon 9. So this is the net resistance in this circuit, 10 by 9. Now in the given circuit, the voltage of BE, which is same as voltage of AF, because you can see that from this circuit, this voltage of B is same as voltage of AF. Okay, so if we find out the current, first of all, current flowing through the B path, so B and E, we will find out the current flowing through in this path BE, because we have to find out the current in this 1 ohm resistance which is in BE path. Okay, so first of all we will find out, and total main is 2 volt, so that will divide here it is 1 volt and here it is 1 volt. Okay, so voltage of B is equal to voltage of AF, which is equal to 1. In this branch 1 volt, in this branch 1 volt, total is 2 volt. Okay, so if you find out, we have to find out the current in this 1 ohm resistance. So we will find out first of all current in this B branch. So net resistance of this B branch, that we know, it is nothing but 2 by 5. Sorry, 5 by 2. This 1 plus 1 in the parallel, 1 and 1, which is 1 by 2, 1 by 2 plus 2, we have find out 5 by 2. In this branch the resistance is 5 by 2. So if we find out the current, I is equal to V by R. So voltage is 1 upon resistance is 5 by 2. So if we take this 2 in the numerator, okay, denominator of the denominator will go in the numerator, so it becomes 2 by 5. So current in the branch BE is nothing but 2 upon 5. But we want the current in this 1 ohm resistance. So here it is dividing this, in this branch current is going 2 by 5. But after that it is dividing into 2 branch here. So we have to do one more half for this 1 ohm resistance. So the total current is going in 1 ohm resistance is half of 2 by 5. So this 2 and 2 will get cancelled. So the net current is going is 1 by 5 ampere through this 1 ohm resistance. Look at the next question. In 4 arms of piston bridge, resistor of value 15 ohm, 12 ohm, 4 ohm and 10 ohm are connected in cyclic order. What will be the value of resistor connected in parallel to 10 ohm? Okay, so resistance as piston bridge get balanced. So it will look like this: 15 ohm, 12, 4, 10. These are connected in cyclic order. So with this 10 ohm resistance, how much resistance will connect in parallel such that this piston bridge get balanced? Okay, so to balance this piston bridge, we have to find out this resistance value R from this option. So we know that the balance condition means ratio of 15 upon 12 and this upon this. So first of all we will find the ratio of relation between this parallel connection. So this 10 ohm and this R that we have to find out, which is in parallel connection. So in parallel we have to just multiply in the numerator, so 10 into R upon 10 plus R. So this is the net resistance of this parallel connection. Now we'll apply the balance condition. So 15 by 12 is equal to 10R upon 10 plus R multiply, and in the denominator will come, it will be 4. So that we'll write here. Okay, this upon this is equal to this upon this. So now we can cancel out this, or we can just okay, here 2 2s are 4, 2 5s are 10. Then we will do the cross multiplication now. So this, okay, let's solve for 15 upon 12 is equal to 5R upon, if we multiply 2 inside, so it become 20 plus 2R. Now if we do the cross multiplication, okay, before doing cross multiplication we can cancel out this also. 3 5s are 15 and 3 4s are 12. So if we cancel out cross multiplication now, so 20 plus 2R multiply with 5. So 5 4s are 5 2s are 10, 100, 25 is 100 plus 5 into 2R 10R is equal to this 4 into 5R, that is 20R. So if we take this 10R this side, so 100 is equal to 20R minus 10R, which is 10R. Okay. Is equal to 100. So if we take this 10 in the denominator, so 100 by 10 is equal to R. So R is nothing but 10. So the correct answer for this question is 10 ohm. We have to connect 10 ohm resistance with parallel here, such that so this Wheatstone bridge will get balanced. Look at the next question. Find out equivalent resistance between A and B. Okay, so this figure is given. A point is here, B point is here. So if we take this point from here and if we move this point A here, okay, then this circuit diagram will look like this, if you look at properly. Okay, and after that, you know, this is nothing but a Wheatstone bridge, and we can easily verify this balance condition, R upon R, which is 1, R by R, which is 1. So the ratio is equal, so no current will flow in this branch. That means this is in series, so R plus R is nothing but R, 2R. This is also in series, so R plus R, this will be also 2R. Then the remaining thing, which is in parallel, 2R and 2R. So 2R and 2R, this is in parallel, so we have to solve in parallel connection. So in parallel, how to solve resistance? If only 2 is there, then just multiply in the numerator both the resistance, so 2R into 2R upon 2R plus 2R. So 2R into 2R, that is nothing but 4R square, divided by 2R plus 2R, that is 4R. So 4 and 4 will get cancelled, 1 R will get cancelled, so net resistance is nothing but R. So the equivalent resistance for this question is R. Look at the next question. The question is, find the currents in 5 kilo ohm and 3 kilo ohm resistance. So 5 kilo ohm resistance is here and 3 kilo ohm resistance is here. We have to find out the current in this resistance, in these branches. So if you see the circuit properly, these 3 resistance of 3 kilo ohm are in parallel. So first of all, we will find out net resistance in this parallel case. So now we will use this 1 upon rule because it is more than 3 resistance. So 1 by 3 plus 1 by 3 plus 1 by 3. So denominator is same. So we just add the numerator. So 1 plus 1 plus 1, that is 3. So 3 by 3, that is 1. So if we take the reciprocal, we will get again 1. So net resistance is 1 kilo ohm. Okay, because all these values are in kilo. Now this 5 kilo ohm, this net resistance is 1 kilo ohm, and this with this here also one more 1 kilo ohm is there. So all these 3 resistance are in series now. So the net resistance is what? 5 plus 1 plus 1, that is 7 kilo ohm. So first we'll find out a current in this 5 kilo ohm resistance. So we have the formula V is equal to IR. So current I is equal to V by R. So V is 21 upon, for this 5 kilo ohm resistance, what will be the current? So 5 into kilo means 10 raised to 3. So if we take this 10 raised to 3 in the numerator, it becomes 10 raised to minus 3. So it is not a 5, this is 7, because we got the net resistance is 7 kilowatts. So 7 into 10 raised to 3. So if we take this 10 raised to 3 in the numerator and this 7th is a 21. So we'll get the answer 3 multiplied by 10 raised to minus 3 ampere. And this we can write down as like this also. 3 into 10 raised to minus 3 means milliampere. So the current flowing through this, let's say this is I1, current is going in this branch is nothing but 3 milliampere. Okay. After that, the same current will flow in the next branch. Okay, so current is moving here 3 milliampere. So it is passing through 3 milliampere from here also. After that, it is dividing into 3 different branches. Okay, so 3 milliampere is dividing into 3 branches. So what is the current in this 3 kilo ohm resistance? 1 milliampere, 1 milliampere, and 1 milliampere, nothing else. Okay, net resistance was 7 kilowatt kilo ohm, and current we got 3 milliampere in this branch 5 kilo ohm, and after that is dividing into 3 branch. So dividing into 3 branch, so we have to do 1 by 3 into total current, that is 3 milliampere. So the current in every this 3 kilo ohm branch is nothing but 1 milliampere. So current in 5 kilo ohm branch is 3, and in the next is 3 kilo ohm branch is 1 milliampere. Okay. Look at the next question. A conductor of length L, area of the cross section A, and resistivity rho, and the resistance R is connected across the cell voltage V. What will be the current flowing through the resistor if its length is doubled? Okay, length is double means new length will be, let's say new length is L1, so it will become 2L, and the cross section area is halved. That means the new area, let's say A1, is nothing but A by 2, original upon 2. So the question is, what is the current? Okay, so if we find out the resistance first, we know the resistance formula is nothing but rho L upon A. But after changing the length and area, the new resistance, let's say R1, so rho is as it is, L become 2L, and A become A by 2, so A upon 2. So the denominator of the denominator will go in the numerator. So this 2 and this 2 will get multiplied. So total resistance become 4 times rho L upon A. Okay. So this is our new resistance. So we'll find out the current. So formula of current is nothing but I is equal to V upon R. So V as it is, we will just substitute the value of R. So R is what? 4 rho L upon A. So 4 rho L upon A. So this upon A will go in the numerator. So the final answer is VA upon 4 times rho L. So which option is it? Is option number A, V into A upon 4 times rho L. Look at the next one. Find the resistance if it dissipates 10 millijoule of energy per second when current of 1 milliampere passes through it. So current value is given 1 milliampere, and we have to find out resistance R. Current is given, and what else is given? If it dissipates 10 millijoule of energy per second. So it is given nothing but in terms of power formula. So we have one formula in terms of power is equal to P is equal to I square R. Okay, we can write down this power. Another formula is work done per time. Okay, so that is only given. It is 10 millijoule energy of per second. Okay, so this 10 millijoule energy per second is nothing but the value of this power. So P is equal to I square R. Power is given 10 millijoule per second. Okay. In terms of work done per time, it is given value. So 10 milli means 10 raised to minus 3 per second means 1 is equal to, current is given 1 milliampere. So 1 milli means 10 raised to minus 3 into R we have to find out. So this 1 into 10 raised to minus 3 will go in the denominator. So 10 into 10 raised to minus 3 upon 1 into 10 raised to minus 3 is equal to R. Okay, here square is there, so the whole square, here whole square will come. So 10 into 10 raised to minus 3 divided by 1 into 10 raised to minus 3 multiplied by 1 into 10 raised to minus 3 is equal to R. So 1 10 raised to minus 3 will get cancelled, and this remaining 10 raised to minus 3 if we take in the numerator, it becomes 10 multiplied by 10 raised to plus 3 is equal to R. So we can write down as, according to option, all the options are given in a kilo ohm. So this 10 raised to 3 is nothing but we can write down in kilo ohm. So the final answer is 10 kilo ohm. Option number C. Let's move to the next question. 500 joules of heat is dissipated when 1.5 ampere of current is passed through the resistor of 20 seconds. So 500 joule of heat is given. So H is given 500 joule. Current I is given 1.5 ampere and passes in 20 seconds. So time T is given 20. The question is, if the current is changed of 3 ampere, it's double it is, then how much heat will dissipate in the same time? Okay, so it is not like that if time is double then heat is double. Our formula to find out heat is nothing but H is equal to I square into R into T. So heat is given, current is given, and time is given. So first of all we will find out the resistance R. Then we'll apply the same formula to find out the heat. So from here resistance is nothing but H upon I square into T. Heat is given to be 500. Current is given 1.5. The square multiplied by time is 20. So we'll solve this. So 500 upon 1.5. So if you remove the decimal point, then it will become 15 upon 10. Square is there, so one more time 15 upon 10 multiplied by 20. Okay. So if we solve this 10 2s are 20. Then this denominator of the denominator will, if you take in the numerator, so it will become 500 into 10 upon 15 into 15, and 1 2 is remaining, right? So this 2 5s are 10, and this 500 we can write down as 5 into 100. Okay, so 5 3s are 15, then 5 3s are 15. So in the numerator 100 and in the denominator 3 3s are 9 will remain. So answer is 100 upon 9. But we don't want to find out the final answer as resistor, so we don't divide this. We'll keep this 100 upon 9 as it is. Okay, so in the exam, don't waste your time to solve this division. We have to find out what the heat. Okay, so again we'll apply the formula H is equal to I square into R into T. So in the second time we have current 3 ampere passing through it, so 3 square multiplied by resistance, we got 100 upon 9, and then time is same, that is 20 seconds. So this 3 square is nothing but 9, so this 9 and this 9 will get cancelled, so 100 into 20, it is nothing but 2000 joule. So if we double the current, then the heat will be 2000. So our option number C is the correct answer. Look at the next question. In the given circuit, find the potential difference across the 10 ohm resistance. Okay, so we have to find out this potential difference across this resistance 10 ohm. So first of all we have to find out the current I, and to find out current I we have to find out the total resistance of this given circuit. So from here you can see that this 20 ohm and 50 ohm are in parallel. So we'll find out that parallel connection first. So 20 multiplied by 50 upon 20 plus 50. So 20 into 50, that is 1000, upon 20 plus 50, which is 70. So 110 will get cancelled, so the resistance will be 100 by 7. Then this 100 by 7, this is the one resistance which is in series with this 10 ohm resistance. So the net resistance is nothing but 10 plus 100 by 7. So if we do the cross multiplication here, so 7 into 10 is nothing but 70 plus 100 by 7. Okay, so total will be 170 by 7. So this is our net resistance. Now we'll find out the current I. So I is equal to V upon R. Our V is given 170 divided by resistance is 170 divided by 7. So this denominator of denominator will go in the numerator, and this 170 will get cancelled. So net current is nothing but 7 ampere. But we have to find out the potential difference across this 10 ohm resistance. So V is equal to IR, potential difference across 10 ohm resistance. So let's say V10 is equal to current is going in this branch is nothing but 7 ampere multiplied by resistance is 10 ohm. So the answer is 7 into 10, 70 volt. So the correct answer is B, 70 volt. So the next question is, this circuit is given. The question is, if there is no deflection in the galvanometer, then find the value of X. Okay, no deflection means it is in the balance condition. So total length of the wire AB is 78 centimeter. Okay, so the total length is 78. Okay, so this is X, and remaining is 78 minus X. And two resistance are given, 6 and 4. So it is given in the balance condition, so we have to just apply the formula. This is our 6 by 4 is equal to the ratio of this length, X upon 78 minus X. So if we do the cross multiplication, then 6 into 78 minus X is equal to 4 into X, that is 4X. So 6 into 78, which is 468, minus 6X is equal to 4X. So if we take this minus 6X that side, so 468 is equal to 4X plus 6X, which is 10X. So if we take this 10 in the denominator, so 468 upon 10 is equal to X. So denominator is 10, means we have to write the point after the one digit from the left side. So 46.8 is our answer. Okay. Look at this question. What will be the most suitable combination of three resistors, 2 ohm, 4 ohm and 6 ohm, so that 22 by 3 ohm is a equivalent resistance of combination? Means after combining the net resistance we are getting 22 by 3. So how we have to connect, which are in parallel, which are in series out of these three, that we have to check. So let's solve one by one option wise. So the first option is parallel combination of A and C connected in series with P. Okay, let's solve the series combination first, because series combination is very easy to find out first. So look at option number C and D. So in C option, series of A and C. So in series combination directly we have to add up. So A and C we have to add up. So 2 plus 6, which is 8. And then the remaining we have to do with parallel with B. So in parallel, how to solve this? 8 and B is 4 ohm. So 1 by 8 plus 1 by 4. So if we make the denominator to be equal by multiplying 2 and 2, so denominator is 8 and 1 plus 1 into 2, which is 2. So 2 plus 1 is 3. Okay. So after taking the reciprocal, we will get 8 by 3. So the option number C is wrong. Then option number D, series combination of B and C. So B and C. So B is 4, C is 6. In the series, the total will be 10. Then parallel with A. So A is 2. So this 10 and 2 are in parallel, so it become 1 by 10 plus 1 by 2. So if you make the denominator to be equal by multiplying 5 in the numerator and denominator, so denominator is now 10, this is 5 ones are 5, and 5 plus 1 6. So if we take the reciprocal, it become 10 by 6, which is not also 22 by 3. So this is also wrong. So C and D both are wrong. Now let's talk about B. Parallel combination of A and B. So A and B is 2 and 4. So in the parallel, how to add? 1 by 2 plus 1 by 4. So if we make the denominator to be same by multiplying 2 and 2, so this become 4, this is 4. So denominator is 4, then 2 plus 1, which is 3. So after that, connected series with C. So C is 6 ohm, we have to add in series. So this is 3 by 4, which is the answer of 1 upon R. So we have to take the reciprocal, so resistance become 4 by 3. Now we have connected with C resistance, which is 6. So 4 by 3 plus 6. So 3 6 are 18. 18 plus 4, which is nothing but 22 upon 3. So we are getting our correct answer. So option number B is correct. That means option number A is also wrong. Okay. Okay. Now this is a very important question. This question has repeated so many times in the NEET exam. So question says a wire of resistance R and length L is cut into 5 equal parts. Okay, this 5 and equal parts are important. If these parts are joined parallelly, then what is the resultant resistance? Okay, so let's say one wire is there, the length is L, the length of this wire is L and the resistance is R. We are cutting this into 5 equal parts, is 2 3 4 5. So if we cut into 5 equal parts, then the resistance will be divided into like this: R by 5, R by 5, R by 5. Means resistance of each part is nothing but R by 5. Okay. Suppose you are cutting one resistance into 10 equal parts, then the net resistance of one part is R by 10, R by 10, R by 10, like that. Okay. So each part has a resistance R upon 5 ohm. Now all this R by 5, R by 5, R by 5, we are connecting in parallel like this. So what is the equivalent resistance? In parallel, how we are adding 1 upon R by 5 plus 1 by R by 5 plus again 1 by R by 5. Okay, so 5 times we have to add R by 5. So all are equal, that means it is nothing but 5 times 1 upon R upon 5. Okay. So denominator of the denominator will come in the numerator. So it will become 5 into 5, 25 upon R. But this is the value of 1 by R. We have to take the reciprocal in the end also. So the final answer is nothing but R upon 25. So this is our correct answer, R by 25. Next question. A rod of length L having resistance R is cut into 2 equal parts. Okay. Now here it is 2 equal parts we are cutting. Then what is the effective resistance of single part? R by 2 and R by 2. These parts are connected in parallel. So in parallel, if we connect it, then 1 upon R by 2 plus 1 upon R by 2. So 1 by R by 2 plus 1 by R by 2 means it is 2 times 1 upon R by 2. So upon denominator of the denominator will come in the numerator. So it will become 2 2s are 4 times 1 by R, means 4 upon R. And this is the value of 1 by resistance in parallel. So we have to take the reciprocal also. So the net resistance is nothing but R by 4. Okay. It is a similar question as of previous one. Look at the next one. In the given circuit, an ideal battery is connected with 4 resistance as shown in the figure. So find the current I mentioned in the diagram. This current we have to find out. Okay, so to find out this current, we'll find out how much current is going from this 10 volt battery. And to find out current, we have to find out first of all total resistance in this circuit. So first we'll start from here. This 4 ohm and this 4 ohm are in parallel. So we'll find out the parallel resistance first. So that 4 into 4 upon 4 plus 4. So 4 4 is 16 upon 4 plus 4, which is 8. So 8 to the 16. So the net resistance in parallel is nothing but 2 ohm. So the starting resistance is 2, and then the parallel solved wave, that is 2, this is 2, and after that it is 1. So now all these three resistance are in series, so we have to directly add up. So 2 plus 1, which is 5. So the net resistance is 5 ohm. So we'll find out the current first. So I is equal to V upon R. So it is 10 upon net resistance is 5, so 10 by 5, which is 2 ampere. Okay, so 2 ampere current is going here, here also 2 ampere. Now at this position, this 2 ampere is divided into two parts. Okay, so 1 ampere will go here and 1 ampere will go here, so the I value is nothing but 1 ampere. Okay, so this two branch way to divide that current. So the I value is nothing but our net current upon 2. So 2 by 2, which is equal to 1 ampere. So the correct answer for this question is B, 1 ampere. Look at this question. This is also a very interesting question. 0.9 ampere current is coming from here, and it is divided into three branches. I1 current is going here. Let's say in this branch I3 current is going, and here it is I2 current is going. In the middle branch I3 current, which is 0.3 ampere, it is already given. Okay, after that again at this position all this current are combining. Okay, so I1 plus I2 plus I3, the total current is 0.9 ampere, out of which we know the value of I3, that is 0.3 ampere. We don't know what is I1 and I2. Okay, so the question is the value of R is, okay, so R is here. Okay, so to find out this R value, we'll use this 20 ohm and 15 ohm resistance. Both are in parallel. Okay, so in parallel connection, the potential is same at this both the point. The potential difference is same. So we can write down as here it is 20 ohm resistance, current is I3, and here it is 15 ohm resistance, current is I1. So potential difference is same. So 20 into I3 is equal to 15 into I1. Okay, we have just simply I into our formula we used. So 20 multiplied by I3, I3 is nothing but 0.3 ampere, is equal to 15 into I1. So from here we will find out I1. 15 will go in the denominator. So 20 into 0.3, that can be written as 3 upon 10. And this 15 will go in the denominator, so it is here, is equal to I1. So if we cancel out 3 5s are 15, 5 4s are 20, and then this is 4 by 10. 4 by 10 means it is nothing but 0.4 ampere. So I1 is 0.4 ampere. We will substitute the value of I1 here. So 0.4 plus I2 plus 0.3 is equal to 0.9. So 0.4 plus 0.3, which is 0.7, and if we take that 0.7 that side, so I2 is nothing but 0.9 minus 0.7. So I2 current is nothing but 0.2. Okay, so we got the value of I2, which is 0.2. Now again this 20 ohm resistance and this R, which is in parallel. So again in this branch also potential difference is same. So we'll again apply the same concept. Current is I2, resistance is R. So I2 into R is equal to this 20 into 0.3, means I3 into 20. So I2 is 0.2, R we have to find out, is equal to I3 is 0.3, and current is 20 in this branch. So we have to find out R. So this 0.2 will go in the denominator. So 0.3 into 20 divided by 0.2. Okay. So in the numerator also after decimal 1 point is there, 1 digit is there. Here also after decimal 1 digit is there. So we can cancel out this point. So 3 into 20 upon 2. So 2 tens are 20, and 3 into 10, which is 30 ohm. Okay, so by using the simple concept potential difference across this parallel connection, we got the value of R, which is 30 ohm.